we've come upon what I've called the train wreck of where we are. Now, we pull up in our emergency vehicle and we assess the situation. Where do we need to go from here? How do we triage this situation we're in? We have 5 speakers for the afternoon session. The first one is Jerry Hiatt from the Nuclear Energy Institute. His talk is on commercial nuclear power, assessing and meeting the need. Now, Jerry he's a senior project manager with the Nuclear Energy Institute, Department of Radiation and Materials Safety, formerly president and chief technical officer of BHI Energy. He's a fellow member of the Health Physics Society and certified health physicist. He's a Health Physics Society William Adams Award, McAdams Award recipient, and serves on curriculum advisory boards on several technical colleges. So I'd like to join me in welcoming Jerry Hiatt.
Hey, Bob, I'm really kind of sorry that Ralph couldn't be here. 2 years ago, Ralph brought me to NEI from after spending 40 years working more in plant at commercial nuclear plants. And in the 2 years since I've been at NEI, I've come to know how much I don't know. So I was going to thank Ralph for helping me learn my own ignorance. But one thing I have learned at NEI is, and I learned this from our government communications people, they said if you're going to share an anecdote and you want to be not too offensive to anyone, quote a president. And a dead one is better. So I read an anecdote that after a particularly long meeting with a rather verbose legislator, as Lincoln was waving goodbye, he turned to his aide and said, "That man can compress the most words into the smallest ideas of any person I've ever met." So my goal is to maybe share less words, but some ideas. And before I even get started, this is probably the easiest presentation I've ever developed because I think I only added 1 or 2 slides. Elizabeth McAndrew Benavides, who is, Liz, can you wave? Liz is the NEI representative who's been responsible for human capital development now for 7 or 8 years. So most of the material that you're going to see here, Liz pulled together. So this made it very easy for me. You can kind of see from the these bullet points that statement number 12, or a sentence from statement 12 from the NCRP said that the magnitude of the shortage varies with the radiation discipline in the practice area. And I think we've already seen that from the earlier presentation. So what I wanted to do today was talk about one specific practice area, and that being the commercial nuclear power industry. And it's going to be a snapshot of where we stand now with some projections on where we're going. I know when Liz was pulling all this data together way back in 2002 and 2003, that's when the industry started recognizing the need. We couldn't have forecast Fukushima. We couldn't have forecast, we were happy to see the nuclear renaissance, but we couldn't forecast what eventually happened, and no one forecast what natural gas prices were going to be. So this manpower development process that the industry's put in together had to absorb all of these kind of changing conditions as well. But just a quick background, the Nuclear Energy Institute is the policy division of the commercial nuclear industry. We're certainly supported by all the nuclear utilities, and our broad mission is to foster the use of nuclear energy in all of its forms. And that gets us into working with legislators. We have a government division, we have a policy division. We also work closely with colleagues at the Nuclear Regulatory Commission and the EPA. We speak as the voice of the industry on proposed regulations. And then we get into acting as a single voice on technical issues or other issues, and that's where the human capital issue really came into play. Elizabeth was pulled together an industry team, and we'll take a look at some of the components here in a moment to take a look at this. This is NEI's working group. roughly 2002, the industry recognized where we were headed and pulled together a working group to take a look at, one, what is the pipeline, and two, what is the demand. And you can see it's not a simple effort. Quite a few organizations are involved. You can see the Health Physics Society, the American Nuclear Society, Institute for Nuclear Power Operations, Elizabeth and Sound Belcher from PHENOC pull all of these groups together, and this makes the working group, been in effect since 2004, 2005. Then they took a look at the needs. And keep in mind, of course, this is working at the overall nuclear workforce, not just radiation protection, but it includes maintenance, electrical, I&C, operators, quality control, the whole gamut. And to look at the need, the nuclear industry, the commercial industry recognizes that we're not in a vacuum, that there are other competing interests as well. The labs, NRC, the military, and each one of these groups may use a slightly different talent pool, but we're still drawing from pretty much the same talent pool. So that was the demand. Now they started looking at the suppliers. Where are the people coming from? And which facet uses the people from which organization? When they started, this closed nuclear plant wasn't a block, but it's a reality. And as sad as it is for the industry, when it comes to manpower needs and pipeline needs, it certainly impacted it. Every 2 years, the industry does a pipeline survey. Well, not a pipeline survey, an overall workforce survey, where Elizabeth will coordinate with all of the HR departments at all of the utilities and ask the HR departments, what are your current statistics? Where do you stand now? And where do you expect to be in the next 5 years? The latest pipeline survey came from data from 2015, and you can see that all 23 utilities supplied data, and in addition, some of the major suppliers of personnel also provided data this time. And Dick showed this slide this morning. This is the status of the industry as of 2015. This only represents utilities. It doesn't represent the suppliers, but as you can imagine, their data is pretty similar to what the industry data was. This slide has a couple of elements on it that weren't on Dick's this morning. The first one is that block in the upper left, where you see that the total employment has dropped. And it's dropped due to the closure of San Onofre and Kewaunee and Vermont Yankee and Crystal River. And it also reflects that for the first time since the industry started collecting data, a little bump in that lower region, which is good. This is the first time the commercial industry has shown that it's starting to get younger. As Dick pointed out this morning, we've still got that double hump, where there's a shortage of the folks in the 30s and the 40s, but it's getting better. And it's getting better in particular in certain work groups. This is the chart for the operations work group. And I think you can see that we are now developing nuclear operators who are younger, which is where we want to be. Now, the two work groups that show the least shift to the youngest are maintenance and radiation protection. But even those are getting slightly better, but they're not going to be, this is a kind of where we want to be as an industry. So from all the presentations this morning, I kind of look at this as being a positive sign, that there are steps you can take to help develop the workforce, and especially help develop the young workforce. But I think you could see from those previous slides on the number of groups involved and the number of the amount of time that was involved in pulling all this together. Sometimes I think as a body, health physicists, the nuclear industry itself, we don't pat ourselves on the back enough. because we do some really good things, and a lot of people don't hear about it. And this is one of the good things that's grown out of this effort, the industry effort, and that's development. Dick referenced it this morning, the Uniform Curriculum Program. When the industry started taking a look at where the most needs were going to be, the initial need was going to be at the technician level, at the maintenance level, at the hands-on kind of levels. We weren't developing the people that we needed. Matter of fact, in radiation safety, there were no two-year programs left. The last one was down at Central Florida Community College, and it stopped in the late, early 1990s. Under the development of the Uniform Curriculum Program, there are now 7 two-year schools graduating radiation safety technicians, and they're all graduating to the same program. This program is set up in accordance with the Institute for Nuclear Power Operations academy documents, so that a student graduating from Aiken Technical College, if they go to work at the Columbia Generating Station in Washington, their degree is recognized as acceptable training, and they're giving full credit for it. The other element that was involved in the Uniform Curriculum Program was working with the two-year schools to develop a relationship with a four-year school so that the courses would all articulate. And when I had the pleasure, before joining NEI, I worked for a company, and we were heavily involved in developing the two-year programs for radiation safety. And when I would go and talk to parents, or I would go and talk to the students, you just tell them it doesn't stop here. I mean, you get your two-year degree, you go to work at the power reactor. The power reactors will probably help pay for you to get your four-year degree and your master's degree. It was an easier sell to parents than it was to students, but it still worked. So these articulation agreements, we're actually seeing some two-year students who are now who now have their bachelor's degree, and they're moving up. This is just a general chart showing that of the two-year degree programs, this has been the placement rate. And this is for all categories, the maintenance, INC, operations. For radiation protection, the placement rate is even higher. It's much higher. And the students not only would go to work at a commercial nuclear plant, some of them have gone to work for some of the environmental companies. Some of them go to work for the supplemental suppliers of radiation safety technician companies. When you're talking to like a 20-year-old and you tell them that you get this thing called per diem, their eyes kind of perk up, and they say, well, what if we share the same room? Well, it stays the same. You don't have to cut it in half. So for some of those folks, the two-year graduates, they've been very, very successful in going on the road. And it really benefits them because they see the way different plants do different things. It gives them a lot of experience very, very quickly. And this is some of the latest data on the number of graduates that we're seeing in the four-year degree programs. And in summary, wanted to talk about, we use the word radiation protection professionals, and of course we're referring mostly to the four-year and advanced degrees folks. But when I think of radiation protection professional, I also think of the technician positions, because I started out as a technician and was able to kind of move up in the organization. But wanted to give you a quick summary of where the industry stands, not only for the health physicist position levels, but also for the technician levels. It's not a major issue currently for the commercial nuclear plants. The uniform curriculum programs are filling the open positions. Elizabeth just picked up the data here that 5% of the workforce, of the radiation safety workforce, is made of graduates from the nuclear uniform curriculum programs. And that's only after about 5 years of the programs being in place. Where the industry continues to see an issue is during those peak refueling outage weeks. When the plant shuts down, they may double or They may double the size of the workforce, and you'll need to bring in more radiation safety technicians for a very short period of time. So we're still having a challenge in meeting those periods. We're meeting it, but it's not as comfortable as we would like for it to be. And the major reason for that is that the plants are all committed to American National Standards Institute requirements that for a technician requires 2 years of experience for that individual to be fully qualified. Interestingly, there is no ANSI requirement for a professional health physicist. But for technicians, it requires 2 years of experience. And working short outages the way it's going now, it can take a technician up to 6 years to accrue those 2 years of experience. So we're having some problems during the peak moments, but the industry hiring itself, the house positions we would call them, well, we're meeting them. We're not having an overall shortage. Now for the health physicist, we recognize that the workforce is aging. You know, if you look at the kind of the bar chart for the health physicist, yeah, it's pushed to the right. I think we all understand that. But it's not at a critical level yet. We're filling the positions that are needed to be filled. The shutdown sites are providing people. Of course, the college graduates from the existing programs are filling positions. And then for short-term kind of positions, we're filling them with consultants or outside vendors. The Workforce Task Force is closely monitoring the radiation safety area. We're kind of their focal point now. So they're keeping a close eye on the number of positions that we have and the number that are going to be needed. But this is where the industry is really focusing, is how are we going to transfer the knowledge from the folks who are there to the incoming professionals. So knowledge transfer within the commercial industry is a critical element currently. And with that, I've kind of succeeded, I hope, in meeting Lincoln's objective of not using too many words and also of keeping his own schedule. So, but I'll be available for questions once the questions are submitted. So thank you.